Hi there, my name is Miss Bankston. We're going to talk a little bit about this theory called the particle theory, which is kind of the basis for everything chemistry. The idea about the particle theory is that everything on Earth is made up of these tiny little particles. You may have heard them called before atoms. And these little particles, we're going to think a little bit more abstractly about them and just how do they behave, because the way that they behave kind of sets everything for chemistry as well. So the first thing that we need to do is talk about the 5 parts of the particle theory. I'm going to go over them in this video, and I would like for you to just write down the title of each of the parts on your sheet. Okay, so when you're finished, you should have all 5 parts listed there and feel like you have a good idea about what each of those 5 things means. After you're finished with that, you'll be able to do the next set of questions. Part number 1 of the particle theory is that all matter is made up of tiny particles. Okay, those tiny particles, which we know are atoms, Everything that you see, everything that you breathe, everything that you feel is made up of these tiny particles. You are made up of these tiny particles. Make sure you write down in that first line on your sheet, all matter is made up of tiny particles. And this picture here is a picture of a quartz crystal, also made up of tiny particles because everything is made of tiny particles. And this would be considered a solid, which has certain properties that we'll talk a little bit more about. If you're looking at a solid, especially a crystal like this one, then you'll see a repeated pattern of these particles. So you can see here that the red and the blue kind of repeat themselves in the same pattern, and when you get a repeated pattern like that, it makes a really pretty crystal like that quartz that you saw. But particles aren't always in these pretty patterns. Sometimes they're kind of wild. Like this, these are little water particles, and water particles flow all over the place, okay? Because they aren't in like a set little pattern, that is why the water can flow. If you had a rock, a solid rock, that rock cannot flow. The particles are stuck where they are, and that's what creates a solid. But the particles in water are free to move about more all over the place, and this makes water flow, but it's also made of particles. The next part in the particle theory is that all particles of one substance are the same. Different substances are made of different particles. Okay, so all particles of one substance are the same. Write that down in your table under number 2. You can see here again, we have that picture. If you remember, these are water particles. Each water particle looks the same. It has 1 red circle and 2 white circles. Okay, if you were to change what that particle looked like, it would no longer be water. Okay, all water, anywhere you find it on Earth, has particles that look just like this. Here is some sulfur, okay, a different substance. It's a very brittle solid. And the particles of sulfur look like this. Each box is considered particle. So you can see that it's a repeated pattern, okay, which makes this more of a solid. These are locked in place. They can't move around freely like those ones in water. You can see they are all connected to each other, but it still is a repeated, it's the same particle over and over again. This is iron. Okay, we've probably seen a pan like this before made of iron, and an iron particle looks like this. Each little circle is a particle. Because this is a solid, these particles are all locked in place, but you can see it's just repeated over and over and over again. So the particles of a substance are all the same. Part 3 of the particle theory, you can write this down on line 3. There are spaces between the particles. Okay, now the amount of space can change depending on if it's a solid, a liquid, or a gas, okay? You can see over here that the particles, each circle is considered a particle. In a solid matter, these particles have a little bit of space between them, but not really. They're touching, right? And they're also moving, which we'll talk about a little bit. They're kind of vibrating. But the important thing here is that there's space, but just a little bit of space. Once you get you get a substance into the liquid state, you have a little bit more space. You can see these ones aren't locked in position like the solid state is, and so while they're moving about, there's a little bit more space between the particles. If you then take that substance and you heat it up even more and it becomes a gas, it can be considered a gas state. And as you can see very clearly here, gas state has a lot of room between the particles. So gas state has the most room, liquid is in the middle, and solid state has the least amount of space between the particles. Part 4 of the particle theory states that the particles are always moving. I mentioned this in the last slide really briefly. The more energy that particles have, the faster that they move. And energy, when we're in chemistry, is often talking about heat. So we could also say the more heat, the hotter that particles get, the faster that they move. So if you think about this in terms of a substance, water, that we know really well. When it's in a solid state, it's ice. It's pretty cold, right? If you give it more energy, you give it more heat, you're going to start speeding up those particles in that ice until they have enough speed to break out of that solid state and move around like we saw in the last slide. When they can start to move around each other, then it is going to flow like water. Water would be the liquid state. Okay, those particles are moving faster than the particles did when it was in solid state. If you continue to give the water more energy, heating it up more, okay, at home, we do this in a pot on the stove, eventually you're going to start to see little bubbles happening, right? Those bubbles, when that water starts to boil, that means that water has gained enough energy or enough heat to turn into a gas. Okay, so gas has the most energy, the particles are moving the fastest, and they have the most space, as we learned in the last slide. So as you take any substance, ice to water water vapor, which is its gas form, each time you make a step and you heat it up more, give it more energy, those particles will move faster and spread out more. And the fifth and final part of the particle theory is that there are attractive forces among the particles. So this just means that these little particles kind of act like little magnets, right? So when these particles are in the solid state, they are very attracted to each other, meaning they are stuck together. Two really strong magnets, you put them next to each other and they're going to stick. There's an attractive force that's going to hold them all together, and that's why if you take like that quartz rock we saw earlier and you set it on the table, it's going to hold its shape because those particles are stuck together really strongly. Okay, when something is in the liquid state, like water, if you were to pour water on the table, the water particles would spread out and kind of take the shape of the top of the table because they're not stuck together as strongly as something that's solid, but it's not like the water's just going to float everywhere in the room. Those water particles still stay together on the table, and that's because there is some attraction still between those particles. When things get up into the gas state of matter, they have some attractive forces between them, but it's very weak. So now they're more like very weak magnets. They're kind of flying around the space, but they're not necessarily going to stick together too closely. It's pretty weak, but those forces are still there. Okay, so make sure you have all 5 parts written down on your table, and then we'll move on to the next practice piece.